The temperature outside is dropping, not the kind of cold that makes you reach for a sweater, the kind that kills. It is somewhere in Europe, roughly 400,000 years ago, and the last orange ember in your group's hearth has just gone black. No lighter, no match, no gas line running under the ground. The fire is gone, and the nearest place where lightning struck a tree dry enough to catch might be 30 miles away. The dark closes in. The predators outside do not sleep. So what actually happened when early humans lost their fire? How did groups survive extinction in a world where body heat was the only thing standing between a sleeping family and the cold? That question has been sitting in the archaeological record for decades. And the answer is stranger, more desperate, and more human than most people expect. Here is the part everyone skips over. Modern humans think of fire as something they make. Ancient humans thought of fire as something they kept. That distinction changes everything. In 2012, archaeologist Francesco Berna and his team at the University of the Witwatersrand published findings from Wonderwork Cave in South Africa. The evidence, burnt bone and plant ash and sediment layers, pushed controlled fire use back to at least 1 million years ago. 1 million. That is roughly 800,000 years before the oldest known written language. Fire was not a recent upgrade. It was older than the human species as it exists today, and yet starting fire from scratch is genuinely hard. Studies in experimental archaeology have shown that friction-based fire starting, the bow drill, the hand drill, the fire plow, requires dry materials, practiced technique, and favorable atmospheric conditions in wet, cold, or high-altitude environments. The failure rate for untrained individuals runs above 90% on any given attempt. For a group with no practiced firemaker and no stored materials, fire was not something they could simply regenerate on demand. Losing it was a catastrophe measured in survival odds, not inconvenience. Here's where it gets strange. The evidence suggests the solution wasn't making new fire. It was carrying old fire. Anthropologist Polly Weisner spent decades studying the Ju Hwansong people of the Kalahari, one of the most extensively documented hunter-gatherer societies on record, publishing key analyses in 2014 in the Proceedings of the National Academy of Sciences. What her fieldwork captured was a picture of fire as something socially managed across communities, not privately owned by a single group. Embers were shared, carried, transported between camps. Archaeologists studying Upper Paleolithic sites across Europe have found evidence consistent with exactly this behavior. Fragments of slow-burning fungi, specifically Fomes fomentarius, the tinder conch mushroom, preserved at sites like T. the Iceman's carry kit from the Alps, dating to around 300 BCA. T wasn't carrying a fire starter. He was carrying a fire, wrapped in birch bark, already lit. The implication for groups 400,000 years earlier is significant. Fire wasn't made at camp. It was managed across networks of people, kept alive across distances that required social trust, route knowledge, and cooperation. Losing fire meant you needed a neighbor. And that need may have been one of the engines that built human sociality in the first place. But there's a problem with this picture. Everyone assumes that the threat of fire loss was primarily about warmth. The truth is, the data points to something else: cooking. Primatologist Richard Wrangham at Harvard University has argued since at least 1999 and elaborated in his 2009 book, Catching Fire: How Cooking Made Us Human, that the caloric unlocking effect of cooking food is so large it may be directly responsible for the reduction of the human digestive tract and the expansion of the human brain. Cooked starches and proteins are dramatically easier to metabolize. Wrangham's comparative analysis found that cooked food delivers roughly 30% more usable energy than the same food eaten raw. 30%. That is not a marginal benefit. For a group hunting and foraging at the edge of caloric sufficiency, which most Pleistocene groups were, a 30% energy reduction is the difference between a functioning immune system and a collapsing one, between children who survive their second winter and children who don't. This means losing fire wasn't just losing warmth on cold nights. It was losing access to the caloric system the human body had restructured itself around over hundreds of thousands of years. The body had already traded digestive mass for brain tissue, betting on fire as a permanent part of the equation. A group that lost fire and couldn't replace it wasn't just cold, it was metabolically stranded. So how did any group recover? The answer is almost certainly social, and the evidence sits in the structure of early human movement patterns. In 2011, researchers studying the archaeological record at Pinnacle Point in South Africa, a coastal cave site with occupation layers going back 164,000 years, found evidence of what appears to be a population bottleneck during a period of severe climatic stress. The groups that survived did not survive in isolation. The genetic and archaeological signatures suggest they maintained contact with other groups across remarkably large geographic ranges. Anthropologist Kim Sterelny writing for Cambridge University Press in his 2012 book The Evolved Apprentice, argued that the transmission of critical skills, including firekeeping, required something that looked more like a structured apprenticeship than simple imitation. Children in early human groups didn't accidentally pick up fire making by watching adults. They were taught, deliberately and repeatedly, because the cost of not learning was death. That teaching relationship meant fire loss had to be recovered at the network level, not the individual level. A single elder who knew how to maintain tinder materials and read conditions for starting a new flame was more valuable to a group's survival than almost any other member. Which also means, and here the twist is sharp, the most dangerous thing that could happen to a group was not losing the fire itself. It was losing the person who knew how to get it back. And yet, everyone assumes early humans lived in constant dread of fire loss. The archaeological evidence suggests something closer to the opposite: obsessive, almost ritualistic fire maintenance that made loss extremely rare under normal conditions. Hearths at sites like Kezem Cave in Israel, studied extensively by archaeologist Avi Gopher and colleagues, with findings published in 2009 in the Journal of Human Evolution, show evidence of continuous use spanning tens of thousands of years. Not the same fire, obviously, but the same location, suggesting generations of active maintenance. The ash layers at Kezem run nearly 3 meters deep, 3 meters of human beings feeding a fire, day after day, probably for hundreds of thousands of meals. That is not behavior that looks like people afraid of fire loss. That is behavior that looks like people who had transformed fire maintenance into something closer to institutional memory. A practice so embedded in daily life, it became invisible, until the moment it wasn't. Which brings everything back to that cold cave, that dead ember. The group that lost its fire in the Pleistocene night had options, but only if they had built the right relationships, trained the right people, maintained the right materials, and stayed close enough to the right neighbors. The ones who had done those things survived. The ones who hadn't left no descendants to tell the story. What ancient humans understood, not as philosophy but as urgent biological fact, is that no single person could hold fire alone. Fire was a social contract. It demanded that people keep showing up for each other, not out of warmth, but because warmth depended on it. Most of what gets called human civilization is really just that same understanding, dressed up in different materials. The cold was never the enemy. Isolation was.